Hi students, in this video I am going to do solve problems and some exercise problems from 4A. Okay. Problem 1. Find the eccentricity, coordinates of foci, length of latus rectum and equation of directrices of the following ellipses. Okay, here are two second degree equations in x and y. The first one is 9x square plus 16y square minus 36x plus 32y minus 92 equal to 0. The second one is 3x square plus y square minus 6x minus 2y minus 5 equal to 0. Okay. These two equations will represent ellipses as there is no xy term in these equations. So this equation will represent ellipses whose axis is parallel to coordinate axis. So we can actually put them in the following form. X minus h whole square by a square plus y minus k whole square by b square equal to 1. Fine. So what we are going to do, we are going to try and express these equations in this form, then we can answer these questions. First let me do this one. First one, solution. So here given equation is 9x square plus 16y square minus 36x plus 32y minus 92 equal to 0. First let me separate x terms and y terms and constants like this. If I take 9 common from x terms, I will have x square minus 4x. Okay. If I take 16 common from y terms, then I will have a y square plus 2y. Okay. Then 92, let me write out here. Okay. I want to complete square from this x terms and y term. So here let me add and subtract 4 here. Okay. Here let me add and subtract 1. Okay. Now from these terms I can complete square, from this term also I can complete square. So 9 times x minus 2 whole square plus 16 times y plus 1 whole square. Here 9 times minus 4 minus 36, 16 times minus 1 minus 16. If I take right side, then I will write 92 plus 36 plus 16. Okay, so now we have 9 times x minus 2 whole square plus 16 times y minus of minus 1 whole square. This one is going to be 144. So if I divide by 144 each side, then I will have x minus 2 whole square by 16 y minus of minus 1 whole square by 9 equal to 1. Okay. So we managed to express given equation in this form: x minus h whole square by a square plus y minus k whole square by b square equal to 1. Here the role of h comma k is what? Played by this 2 comma minus 1. So this is going to be our center, and here a square equal to 16, b square equal to 9. Here we have a greater than b case, so we have a short and fat ellipse. Okay, fine. So in a greater than b case, eccentricity formula what? Equal to under root 1 minus b square by a square. Okay, so what is the b square we have here? B square is 9, a square is 16. So we have this root 7 by 4. Okay, so eccentricity E value root 7 by 4. Okay, and we know for a greater than b case, the foci coordinate is going to be what? H plus or minus ae comma k. Okay, first of all, what is ae here? Ae 4 times root 7 by 4, it's going to be root 7. Okay, so the foci h plus or minus ae comma k going to be, what is h here? 2 plus or minus AE going to be root 7 comma K. K is minus 1. So we have 2 plus root 7 comma minus 1, 1, 2 minus root 7 comma minus 1. So these are the two focus foci. Fine. Okay. Next, length of the lattice rectum. For A greater than B case, we know the length of the lattice rectum equal to 2b square by A. Okay. So what is B square? We have 9 by A. A going to be 4. So it's going to be 18 by 4. Fine. Okay. Next, equation of directrices. We know that directrices equation, what are directrices here? X equal to h plus or minus a by e. First of all, what is a by e? A by e going to be a is 4, e is root 7 by 4. So we have 16 by root 7. Okay. So the directrices equation going to be x equal to h. What is h here? 2 plus or minus 16 by root 7. Okay. So we have two directrices here. X equal to 2 minus 16 by root 7, 1. X equal to 2 plus 16 by root 7. Okay. Fine. So we are done with the first question. Now let us answer the second one. Now the second equation, 3x square plus y square minus 6x minus 2y minus 5 equal to 0. Okay. Again, let me separate x terms here. If I take a 3 common from x terms, we have x square minus 2x, okay, and y square minus 2y. So 5 I am writing out. Now to complete square from this x terms and y terms, here I want to add 1 and subtract 1. Here also I want to add 1 and subtract 1. Okay. From this I can complete square here, x minus 1 whole square. From this I can complete square like a y minus 1 whole square. Now if I take 3 times minus 1, minus 3 and minus 1 right side, then I will have 5 plus 3 plus 1, okay, that's going to be 9, okay. Now if I divide each side by 9, then I will have x minus 1 whole square by 3 plus y minus 1 whole square by 9, okay. Now, if you compare with this equation, x minus h whole square by a square plus y minus k whole square by b square equal to 1. Here h comma k role played by the point 1 comma 1. A square is going to be 3, b square is 9. So here a less than b case. That means we have a tall and skinny ellipse, right? Okay. Now find. Now first of all, a is going to be root 3, b is going to be 9. Okay, first eccentricity, when a less than b case, eccentricity formula going to be this, e equal to under root 1 minus a square by b square. Okay, this is under root 1 minus a square is 3, b square is 9. So we have a under root 1 minus 1 by 3, which is going to be 1 minus 1 by 3, that will be equal to under root 2 by 3. Okay, fine. That is the eccentricity. Fine. Now, so we got eccentricity. Foci. What are foci coordinates? For a less than b case, foci coordinates going to be h comma k plus or minus b. Okay, first of all, what is BE here? BE. B is 3 and E is root 2 by 3. So it's going to be root 6. Okay, so B is going to be root 6. So the 4C coordinates I can write now. H, what is H here? 1, comma, K also 1, plus or minus BE we got root 6. Okay, so we got like a 1 comma 1 plus root 6, one focus, 1 comma 1 minus root 6, another focus. Fine. Next, length of the lattice rectum. Okay, in A less than B case, we know the length of the lattice rectum in terms of A and B going to be this 2A square by B. Okay, so 2, what is A square? We got 3 by B also 3, so it's going to be 2. 3 cancel. So the length of the lattice rectum is 2. Next, equation of directrices. Okay, for A less than B case, directrices is going to be two horizontal lines, which are directrices equation is going to be y equal to k plus or minus b by e. First of all, let us see what is b by e. Here b is 3 and e we got root 6. So it's going to be root 3 by root 2. So root 3 by 2. Okay, b is going to be root under root 3 by 2. So the equation of the directress is y equal to k. K is 1 plus or minus root 3 by 2. Okay. So y equal to 1 minus root 3 by 2, one directrix, and y equal to 1 plus root 3 by 2, another directrix. Okay. Fine. Next, problem 2. Find the equation of the ellipse referred to its major and minor axis as the coordinate axis x and y respectively, with a lattice rectum length 4 and distance between 4C 4 root 2. Fine. Okay. Here we want an equation of an ellipse whose major axis precisely x-axis, whose minor axis precisely y-axis. So that means our equation going to be in standard form. Okay. Fine. Okay. So here we are going to find equation for standard ellipse. It looks something like this. Okay. Okay. A dash, A, S dash, yes. Okay. Fine. This is x-axis, y-axis. Okay. Okay. We know the standard equation of an ellipse will be in this form: x square by a square plus y square by b square equal to 1. We just start to figure out what is this a square, what is this b square. Fine. And also here our major axis should be on this x-axis, so we are in a greater than b case. Okay. Okay, what is given here? Lattice rectum length 4, distance between 4C 4 root 2. What is the length of the lattice rectum for A greater than B case? Length of the lattice rectum here it is given 4. We know for A greater than B case, the length of the lattice rectum formula is 2b square by A. So we are kind of given the 2b square by A value 4. That implies b square is going to be equal to 2a. Let me call it 1. Okay. Now what else is given? Distance between 4C. As we know, the s dash coordinates are minus ae comma 0 and s coordinates are ae comma 0. So this distance is going to be 2ae. So we are kind of given 2ae value 4 root 2. That implies ae value 2 root 2. Okay, fine. Let me call it 2. Okay. Now we have a relation between A, B and E. When A greater than B case, we have this B square equal to A square times 1 minus E square. That implies B square equal to A square minus AE whole square. Okay. So B square I can write with 2A from 1, A square as it is. This AE whole square I can write this 2 root 2 whole square. So this will give me a quadratic equation in A. So we have A square minus 2A minus 8 equal to 0. Let me call it 3. So if you try to solve this equation for A, so what you get here? So A square minus 4A plus 2A minus 8 equal 0. So if you write A times A minus 4 plus 2 times A minus 4 equal to 0. So we have A plus 2 times A minus 4 equal to 0. That implies A equal to minus 2 or A equal to 4. But A is what? Distance from the center to this vertex, that cannot be negative. You can also call it semi-major axis length. Okay, so that cannot be negative, so we have to discard this option. Okay, so we have to go ahead with A equal to 4. Now you got A equal to 4, that implies A square equal to 16. So if you take A value, put it in 1, so B square will be what? 2 times 4, that will be B square value 8. Okay, therefore what will be our equation now? X square by 16 plus y square by 8 equal to 1. So this is the equation of an ellipse. Okay. Next, problem 3. If the length of the lattice rectum is equal to half of its minor axis of an ellipse in the standard form, then find the eccentricity of an ellipse. Okay. Here we are to find eccentricity of an ellipse. Okay. First, let me take our standard equation of an ellipse. X square by A square plus Y square by B square equal to 1. Here I am considering A greater than B case. Even if you take A less than B case, still you would end up with the same eccentricity with this problem. Okay, it's fine. Now, so that means we are considering shortened fat ellipse like this. Here A dash major axis, B dash minor axis. Okay, here the B coordinate is going to be 0 comma B, 0 comma minus B. So this length of the minor axis will be 2B, right? Okay. And also, if here is a focus, this is the lattice rectum. Okay, length of the lattice rectum equal to 2B square by A when A greater than B case. Fine. Okay, fine. Here, what is given? The length of the lattice rectum equal to half of its minor axis length. So that means length of the lattice rectum, that is 2B square by A, equal to half of the minor axis length, that is 2B. So it's going to be, that implies we will have, okay, 2B equal to A. Okay, we got this relation, 2B equal to A. Okay, from this I can actually write 4B square equal to A square. Okay, now the eccentricity formula in terms of A and B, for A greater than B case, it's going to be under root 1 minus B square by A square. Okay, so under root 1 minus, so B square, A square let me replace with 4B square. Okay, then we have under root 1 minus 1 by 4, it's going to be root 3 by 2. Okay, so eccentricity E we got root 3 by 2. Fine. Problem 4. If theta 1, theta 2 are the eccentric angles of the extremities of a focal chord other than vertices of a ellipse x square by a square plus y square by b square equal to 1. Here a greater than b case and E its eccentricity, then show that E times cos of theta 1 plus theta 2 by 2 equal to cos of theta 1 minus theta 2 by 2. And second one, E plus 1 by E minus 1 equal to cot of theta 1 by 2 times cot of theta 2 by 2. Okay. Fine. Here we have a standard ellipse. Okay, whose equation x square by a square plus y square by b square equal to 1. Here we have a greater than b case. Okay, so we have a short and fat ellipse like this. Okay, so here is the center. Let us say this is the focus whose coordinates are AE comma 0. Okay, so the focal chord that we are considering other than these vertices. Here A dash also going to be focal chord. Okay, but we are not considering A dash. Okay, so other than vertices. So some focal chord, something like this. Okay, this is a focal chord. What is the focal chord? Chord passing through focus. Okay, so whose extremities, let us say P and Q. Here theta 1, theta 2 are the eccentric angles of the extremities of the focal chord. Okay, so let us say theta 1 is the eccentric angle of the point P. Then in parametric form, the P coordinates must be A cos theta 1 comma B sin theta 1. Okay, if I say theta 2 is the eccentric angle for this point Q, then Q coordinates in parametric form must be A cos theta 2 B sin theta 2. Okay, this PQ chord is focal chord, right? That means this SPQ must be collinear. Okay, so if SPQ are collinear, then we should have slope of SP same as slope of this SQ. Okay, so the slope of SP will be B sin theta 1 minus 0 by A cos theta 1 minus AE. Slope of SQ will be B sin theta 2 minus 0 by A cos theta 2 minus AE. Here both sides, this B get cancelled, this AA, if you take a common, okay, these things get cancelled. Then we will be left with, sin theta 1 times cos theta 2 minus E equal to sin theta 2 times cos theta 1 minus C. Okay, so if I take E terms one side, okay, and remaining things one side, what I can get here, sin theta 1 cos theta 2 minus sin theta 2 cos theta 1 equal to, so then we have E common sin theta 1 minus sin theta 2. Okay, fine. So this one we can write sin A minus B form. So sin theta 1 minus sin theta 2. Now sin theta 1 minus sin theta 2 using sin C minus sin D form, I can write 2 cos theta 1 plus theta 2 by 2 times sin theta 1 minus theta 2 by 2. Okay, again the sin theta 1 minus theta 2 we can write 2 sin theta 1 minus theta 2 by 2 cos theta 1 minus theta 2 by 2. Okay, now this one cancel. Okay, and what we have here, and this 2 get cancelled. Okay, then we left with what? E cos theta 1 plus theta 2. That's what we left with right hand side. Okay, left hand side thing, what we have here, cos theta 1 minus theta 2 by 2. Okay, fine. This is what the first one. Okay, we are done with the first part. Now let us do the second one. Okay, the second one actually follow from the first one. From 1, what we have, we can actually write E by 1 equal to cos theta 1 minus theta 2 by 2 by cos theta 1 plus theta 2 by 2. Okay, by using something called componendo and dividendo, so this will be equivalent to E plus 1 by E minus 1. Okay, cos of theta 1 minus theta 2 by 2 plus cos of theta 1 plus theta 2 by 2 by cos of theta 1 minus theta 2 by 2 minus cos of theta 1 plus theta 2 by 2. Okay, here the numerator, okay, here the right hand side numerator we can see in cos c plus cos d form, denominator we can see in cos c minus cos d form. Cos c plus cos d is what? 2 cos of c plus d by 2 times cos of c minus d by 2, and cos c minus cos d is 2 sin of c plus d by 2 times sin of d minus c by 2. Okay, so here our c going to be theta 1 minus theta 2 by 2, d going to be theta 1 plus theta 2 by 2. So if you work with the numerator here, 2 cos of c plus d by 2 will be simplified to theta 1 by 2. Okay, and c minus d by 2 here is going to be cos of, okay, c minus d by 2 going to be minus theta 2 by 2, but you don't have to write minus cos minus theta same as cos theta, right? So we can simply write theta 2 by 2. Okay, fine, that is numerator. Now the denominator look like a cos c minus cos d. What is the cos c minus cos d? 2 sin of c plus d by 2 times sin of d minus c by 2. Okay, here our c going to be theta 1 minus theta 2 by 2, d going to be theta 1 plus theta 2 by 2. So if I write it, 2 sin of, again c plus d by 2 will be simplified to theta 1 by 2, and d minus c by 2, that is theta 1 plus theta 2 by 2 minus of theta 1 minus theta 2 by 2, it's going to be simplified to theta 2 by 2. Okay, fine. So sin of theta 2 by 2. As you can see, this 2 and 2 got cancelled. This cos theta 1 by 2 by sin theta 1 by 2 we can write cot of theta 1 by 2. Cos theta 2 by 2 by sin theta 2 by 2 we can write cot of theta 2 by 2. Okay, so left hand side we have e plus 1 by e minus 1. Left hand side we have e plus 1 by e minus 1. Okay, fine. Problem 5. C is the center, A dash and B dash are major and minor axes of the ellipse x square by a square plus y square by b square equal to 1. If Pn is the ordinate of the point P on the ellipse, then show that Pn square by a dash n times an equal to bc square by ca square. Okay. Here, this is the standard ellipse, axis, x-axis, y-axis. Okay. Here is the center. whose equation here x square by a square plus y square by b square equal to 1. Here we are considering the case a greater than b. Okay, so here a dash a, these are vertices. Okay, ends of the major axis, b b dash, ends of the minor axis. We also know the coordinates of a dash, a comma 0, minus a comma 0, 0 comma b, 0 comma minus b. Center is 0 0. Okay. Now P is a point on this ellipse. Let us say here is a P. Okay. So if I want to write parametric form for this point, so we can write A cos theta comma B sin theta, where theta is eccentric angle of this point P. Okay, fine. If Pn is the ordinate of the point P, that means if I draw perpendicular onto axis, okay, it meets at some point N. This Pn is exactly ordinate of the point P. So here Pn equal to ordinate of the point P, that is B sin theta. Okay, and the Cn, this Cn is going to be abscissa of the point P, so it's going to be Cn equal to A cos theta. Fine. And here Ca equal to Ca dash equal to A, and Cb and Cb dash equal to B. That's fine. Now let us start with LHS. Here left hand side, Pn square by A dash n times An. We are starting with LHS. What is Pn? So the numerator Pn is the ordinate of the point P, that is B sin theta, okay, whole square by A dash n. Here this A dash n we can write as Cn plus Ca dash. That is Cn is what? A cos theta, Ca dash is A. So it is going to be A times 1 plus cos theta. Okay. Next An. Okay. Next An. This An we can write as Ca minus Cn. Okay. So this An I can write as Ca minus Cn. Ca actually A, but Cn again A cos theta. So An is going to be A times 1 minus cos theta. So this A dash n I can write A times 1 plus cos theta, and this An we can write A times 1 minus cos theta. Okay, so now we have B square sin square theta by A square 1 minus cos square theta. Okay, and we know, okay, now 1 minus cos square theta nothing, okay, and we know 1 minus cos square theta is sin square theta, so these two get cancelled. So we have this B square by A square. Okay, now B we can write CB, so it's going to be CB square by A we can write CA, CA whole square. So therefore we have LHS equal to RHS. Okay, so we have LHS equal to RHS. Done. Next, problem 7. Show that among the points on the ellipse x square by a square plus y square by b square equal to 1, a greater than b case, minus a comma 0 is the farthest point and a comma 0 is the nearest point from the focus a comma 0. Okay, here we have a standard ellipse whose equation is x square by a square plus y square by b square equal to 1. Here a greater than b case, so we have a short and fat ellipse like this. So this is x-axis, y-axis, okay. Here we have a center 0, 0. These are the vertices a dash, okay. A is what? A comma 0, a dash is minus a comma 0, okay. Fine. Here is the one focus, yes, whose coordinates are AE comma 0. Okay. From this figure, it is pretty clear that A is the nearest point to focus on the ellipse and A dash is the farthest point to the this focus. Yes. Okay. That means if I take any point on the ellipse P, then this SP will be bigger than this SA and smaller than this SA dash. That's what we have to show. That means for this focus SAE comma 0, that means for this focus AE comma 0, A is the point which is the smallest focal distance and A dash is the point on the ellipse which is the largest focal distance. That means if you take any point P on the ellipse, the focal distance of that point will be bigger than this A and smaller than this A dash. Okay, that's what we have to show. Okay. Okay, let Px1, y1 be any point on ellipse. Okay, then we know the focal distance Sp will be equal to a minus Ex1. Okay, we have already seen that. Okay, focal distance of the point x1, y1 going to be a minus Ex1, right? Okay, I want to show that SA less than or equal to SP less than or equal to SA dash. Okay. Then we can say that A is the point on the ellipse which having smallest focal distance and A dash is the point on the ellipse which having largest focal distance. Okay, fine. Since x1, y1 is a point on the ellipse, okay, ellipse is a bounded curve, so here x1 must be between minus a to a, right? Now, if I multiply e each side, e is the positive, right? So we have same side inequality minus ea less than or equal to ex1 less than or equal to ea. Again, if I multiply minus each side, then inequality get reversed. Then we will have EA greater than or equal to minus EX1 greater than or equal to minus EA. So let me write like this. Minus EA less than or equal to minus EX1 less than or equal to EA. Now, if I add A each side, then we will have A minus EA less than or equal to A minus EX1 less than or equal to A plus EA. Okay, fine. Okay, now you can see that this A minus EA actually this SA because this is A, right? Distance from C to A and distance from C to S is AE or EA. So now CA minus CS going to be SA. Okay, so that's why, so this will be exactly SA and this is less than or equal to, and A minus EX1, that is the focal distance of the point P, so this is going to be SP which is less than or equal to A plus EA. Okay, now so this is A and this is AE. So now A plus AE going to be what? Distance from this S to A dash. So A plus EA going to be equal to SA dash. As you can see, we have SA less than or equal to SP less than or equal to SA dash for any point on the ellipse. Okay, so that means we can say A is the nearest point on the ellipse to the focus SA comma 0, and A dash is the farthest point on this ellipse from this focus AE comma 0. Fine. Therefore, we can say this minus A comma 0, that is A dash, is farthest point from S, that is AE comma 0, and A, which is A comma 0, is nearest point on the ellipse. Of course, both are points on the ellipse from the focus AE comma 0. Okay, fine. Problem 8. The orbit of the Earth is on ellipse with eccentricity 1 by 60 with the Sun at one of its foci. The major axis being approximately 186 times 10 to the power of 6 miles in length. Find the shortest and longest distances of the Earth from Sun. Okay, fine. Here is an orbit which is an ellipse. Sun is at the focus, yes, okay, and let us say this is a major axis A dash, okay, here it will be center, fine. So the Earth moving on this orbit, okay, which is ellipse, fine. So from the previous problem, we know that the point on the ellipse which is nearest to the focus is this vertex A, and the point on the ellipse which is farthest to the focus is this vertex A dash. Okay, that means when Earth is at this vertex A, then we will have a shortest distance from Earth to Sun. When Earth is at this vertex A dash, then we will have longest distance from this Earth to Sun. Okay, and we also know that this SA actually A minus AE, this AC dash actually A plus AE. Okay, here what is given? Eccentricity of this ellipse is 1 by 60. Okay, and the major axis length, that is 2A, equal to 186 times 10 to the power of 6. That implies A equal to 93 times 10 to the power of 6. Okay, now we got A and E. So now we can answer the longest distance of the Earth from Sun equal to A plus AE, that is A times 1 plus E. So A is what? 93 times 10 to the power of 6 times 1 plus 1 by 60. This gets simplified to 9455 times 10 to the power of 4 miles. Okay. Now the shortest distance of the Earth from Sun will be equal to A minus AE, that is A times 1 minus E. Okay, so A value 93 times 10 to the power of 6, 1 minus 1 by 60. This gets simplified to 9145 times 10 to the power of 4 miles. Okay, it is simply application of the previous problem. Okay, fine. Next, Problem 3 from section 1 of the exercise 4a. Find the equation of the ellipse in the standard form such that distance between foci is 8 and the distance between directrices is 32. Okay, here, so we want equation of the ellipse in standard form, x square by a square plus y square by b square equal to 1. Let me assume a greater than b case. Okay, here we need to know what is this a square and b square. Fine. Okay, here this is the standard ellipse. Okay, here this is the focus s dash. Yes, s coordinates are ae comma 0 minus ae comma 0. Here is the directrix whose equation is x equal to minus a by e. Here is the directrix x equal to a by e. It is pretty clear that distance between these two directrices equal to 2a by e and distance between foci equal to 2ae. Fine. Okay, what is given here? Distance between foci, that is 2ae equal to 8, that implies ae equal to 4. Let me call it 1. And distance between directrices equal to 32, that is 2a by e equal to 32. That implies a by e equal to 16. Let me call it 2. Okay. Now if I multiply 1 and 2, what you get? ae times a by e equal to 4 times 16. So a square equal to 64. I got a square. That implies a value 8. Again, from 1, if I plug in this a value, so 8 times e equal to 4, that implies e equal to 1 by 2. So we got eccentricity e also. Okay, now we want b square. Now we have a nice relation between a, b, e. We already know a and e. We can go for b. So we have relation b square equal to a square times 1 minus e square when a greater than b case. Okay. So the b square going to be a square, that is 64 times 1 minus e square going to be 1 by 4. Okay. Now we have this 64 times 3 by 4. Okay. So it's going to be 16 times 3, that is 48. Okay. Therefore, our equation is going to be x square by 64 plus y square by 48 equal to 1. Okay. Next, problem 5 from section 1 of the exercise 4a. The distance of a point on the ellipse x square plus 3y square equal to 6 from its center is equal to 2. Find the eccentric angles. Here is the solution. Okay, first of all, the given ellipse x square plus 3y square equal to 6. If I write in standard form, it's going to be x square by 6 plus y square by 2 equal to 1. Okay, fine. Here a square equal to 6, b square equal to 2. Here we have a greater than b case. Fine. Okay, now let us say P is a point on this ellipse. Okay, so in parametric form, this point must be in this form. Okay, a cos theta. Here a is, so a will be root 6, b will be root 2. So it should be root 6 cos theta root 2 sin theta, where theta is eccentric angles. Okay. Here see the center which is 0, 0. Okay. Let us say this P is a point such that Cp equal to 2. Okay, here if Cp equal to 2, then what should be these eccentric angles for this point P? Okay, now, okay, what is Cp under root 6 cos square theta plus 2 sin square theta, distance from 0, 0 to root 6 cos theta comma root 2 sin theta equal to 2. Okay, if I take square both sides, then I have 6 cos square theta plus 2 sin square theta equal to 4. Okay, so then I can write 3 cos square theta plus sin square theta equal to 2. Okay, now I can write 2 cos square theta plus cos square theta plus sin square theta equal to 2. Here this 3 cos square theta I am writing 2 cos square theta plus cos square theta. So now this will be equal to 1. Okay, so now we have 2 cos square theta equal to 2 minus 1, it will be 1. That implies cos square theta equal to 1 by 2. That implies cos theta equal to plus or minus 1 by root 2. Okay. Now, if you solve this trigonometric equation, you will see that theta equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Okay, so these are eccentric angles of the point P whose distance from center is 2. Okay, fine. Okay, problem 7. If the ends of major axis of an ellipse are 5, 0 and minus 5, 0, find the equation of the ellipse in the standard form if its focus lies on the line 3x minus 5y minus 9 equal to 0. Solution. First of all, we are looking for standard equation of the ellipse x square by a square plus y square by b square equal to 1. Okay. Here it's going to be a greater than b case, okay, because major axis ends are lies on x axis, so it must be a greater than b case. Here minus 5 comma 0, 5 comma 0, it's going to be a dash and a, which are ends of the major axis, so our ellipse will be something like this. Okay, if you say this is a focus S, what will be S coordinates? First of all, the major axis length A dash equal to 2A, that is going to be 10, that implies A equal to 5. So this S coordinates must be 5E comma 0. Okay, so that implies A square equal to 25. Now we already got this A square, now we need to figure out B square. Okay, so first we can actually find out eccentricity E. Once we know eccentricity and A, we can go for B because we have a relationship between A, E, B, right? So what else is given? Here the focus lies on the line, okay? This line, let us say 3x minus 5y minus 9 equal to 0. Okay, so if you substitute the point 5e comma 0 in the line equation, here, okay, here the focus 5e comma 0 lies on the line 3x minus 5y minus 9 equal to 0. So that means 3 times 5e minus 5 times 0 minus 9 equal to 0. That implies E equal to 9 by 15, that is 3 by 5. So we got eccentricity 3 by 5. Okay, now we have a relation when A greater than B case. Okay, the relation is this: B square equal to A square times 1 minus E square. Okay, now the B square going to be A square, we already got 25, 1 minus E square going to be 9 by 25. Okay, so So 25 times 25 minus 9 by 25. So 25 cancel. It's going to be 16. So the b square value 16. So our equation going to be x square by 25 plus y square by 16 equal to 1. So this is the equation of an ellipse. Problem 2 from section 2 of the exercise 4a. I'm not going to do this problem in full details, but I'll give you outline. Find the equation of ellipse in the form x minus h whole square by a square plus y minus k whole square by b square equal to 1, given the following data. Okay, in the first question, here center is given, that is h comma k given right away. Now, if you want to write down equation in this form, you need to know a square and b square. But a square, b square not given directly. We are given one end of the major axis, that is 2 comma minus 5, and eccentricity given. Here you can see that the center and this one end of the major axis lies on vertical line x equal to 2. Okay, here center could be somewhere 2 comma minus 1, then one end of the major axis is going to be somewhere here. Okay, 2 comma minus 5. Okay, now you see this major axis parallel to y axis. Okay, so that's why you have to treat this one as some b dash. Okay, this is center C, and end of the major axis you have to take as a b dash. So the distance from the center to b dash is going to be b. Okay, so if you call it b dash, then cb dash is going to be equal to b. Okay, now you got a b value, that implies you can find out the b square value, and eccentricity given. Now, so this is going to be a less than b case, because major axis is parallel to y axis means, so you are getting tall and skinny ellipse. So we have a less than b case. In that case, we have this relation b square equal to a square times 1 minus e square. Okay, so using this relation you can get a value. Okay, so you know b square. Okay, now you know eccentricity. From this relation you should be able to find a square value, then you will be able to write down this equation. Okay, fine. Similarly, if you look at the second one, here again center h comma k given, one end of the major axis minus 1 comma minus 1. Now this time the center and one end of the major axis lies on horizontal line. Okay, so if you think, you know, this is a y equal to minus 1 horizontal line. Okay, so here if this is the center 4 comma minus 1, okay, then one end of the major axis minus 1 comma minus 1. Okay, so if this is C, you should treat this one like a dash, because here the major axis parallel to x axis, so it's going to be short and fat ellipse. Okay, so you have to take distance from the C to a dash as a. Okay, this is going to be a greater than b case. Okay, in the second problem you will get an ellipse equation with a greater than b case. Okay, now you got a value. Okay, now fine, so you can get a square, that implies you can get a square. Now you know a square, you know h comma k, all you need to figure out b square. But what is given here? Eccentricity is not given, but it is given that this equation passes through the point 8 comma 0. Okay, so using that condition you can get b square directly. We don't need eccentricity here. Okay, fine. Next, in the third question, if the center is given, center h comma k given 0 comma minus 3, and eccentricity given 2 by 3, and semi minor axis length is given. See, so if this is a ellipse, okay, center a dash, So this CA is a semi-major axis. The CB is going to be semi-minor axis. Similarly, CA dash, CB dash. Okay. So there are two cases here. So if you are considering A greater than B case, semi-minor axis length means B equal to 5 is given. Okay. If you do that, you will get 1. Next case, if you consider A less than B case, that means this A equal to 5 is given. Okay. In that case, you will get another ellipse. Okay. You have to do in two cases. Okay. For example, if you consider A greater than B case, so semi-minor axis length 5 is given. So B equal to 5 is given. So and eccentricity also given here. So from that you can get the A value. Actually we have a relationship between A, B, E, but we already know E and B, so we can figure out A. When A greater than B, we have this relation, B square equal to A square times 1 minus E square. Okay, from this relation you can get A value. In this case, A less than B case, A equal to 5 is given. Okay. Now in this case, the relation is going to be this: A square equal to B square times 1 minus C square. Now you know A and E, from that you can get B value. Okay, fine. And in the fourth question, again center H comma K given, 0 comma minus 3, and eccentricity E is given, and length of the lattice rectum. There are two cases again. If we consider A greater than B case, then 2B square by A is given, 4. Okay, from that you have one relation, B square equal to 2A. Okay, now we also have one more relation when A greater than B, that is B square equal to A square times 1 minus E square. So E is given. If you plug it here, from these two you can get A value, from that you can get the B value. Okay, so that you can write down this equation. Okay, next case, if you consider A less than B case, then the length of the lattice rectum going to be 2A square by B. That's what is given. Okay, again similarly, so A square is going to be 2B. Now when A less than B, the relation between A, B, E will be this: A square equal to B square times 1 minus E square. Here E is given. Okay, now from these two, okay, you should be able to get B value. Okay, from that you can get A value. Okay, fine. I hope you can proceed now. Fine. Okay, let me stop now. Okay, thank you.